Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When dicarboxylic acids are heated, they may undergo decarboxylation or cyclodehydration and hydride formation, depending on the geometry and chain length of the acid. Moving on to the next step. Malonic acid, CH2, readily undergoes decarboxylation on heating to give acetic acid and CO2. So it is affected. Moving on to the next step. Malic acid is the cis-butenidic acid. Because the two carboxyl groups are on the same side of the double bond, they are held in close proximity. On heating, malic acid readily undergoes intramolecular cyclodehydration to form malic anhydride. So it is affected. And for the final step, fumaric acid is the transbutenidic acid. Because the two carboxyl groups are on opposite sides of the double bond, they are far apart and cannot approach each other to form a cyclic anhydride. Fumaric acid cannot undergo decarboxylation easily either under moderate heating conditions. Thus, fumaric acid remains unaffected on heating. It only converts to malic acid at very high temperatures, but under normal heating conditions it does not react. This is the key distinction. The trans geometry prevents anhydride formation. Succinic acid, CH2, on heating forms succinic anhydride, a 5-membered cyclic anhydride, readily. So it is affected. Why other options fail? A. Decarboxylates. B. Forms anhydride due to cis geometry. D. Forms cyclic anhydride. Only fumaric acid, C, cannot form a cyclic anhydride due to its trans configuration and does not easily decarboxylate, so it remains unaffected on heating. Therefore, the correct answer is C. Therefore, the correct answer is option C.